Hi, all my JavaScript friends. This is the Virtuoid, and this is Fun with JavaScript, where we create fun projects together. If you like this video, make sure to hit the like button below and hit the subscribe button to see all of the wonderful things we're going to be doing with our Fun with JavaScript series. Well, hello, all my JavaScript friends. We're going to now start with the base card class. Now, we're going to be doing test-driven development here, and that test-driven development basically means that we're going to write our test, and then we'll develop based upon whether those tests succeed or fail. Most likely succeed. I mean, that's really what we want to do, is to have tests succeeding. And once all our tests are succeeding, assuming all our tests cover everything we want to cover, we're going to have a fully functional class. So let's get started first with the test-driven development. Now, I've already done npm init on my repository here. So the next thing we're going to do here is install Cypress. And it just happens to be my choice. And I'll let it do its thing, and I'll come see you once it's all done. Okay, Cypress is all done. And so the next thing we want to do here is we want to now open it up and have it initialize all the different files for us. And to do that, it's real simple. And so this will open up this will have Cypress initialize all the files for you automatically. And I'll come back to you when it's done. Okay, Cypress is done, and we'll give you this little window here telling you everything that it has created for you. We don't really care about this at this particular point in time, so we'll just click on the X. That will exit our program, and then that program, and then we're back to our regularly scheduled CLI prompt. So let's flip over to our code here. And as you can tell, it added a whole bunch of fun little stuff in there, and I have not added any of these files to Git. So let's go ahead and get them into Git, which you don't really have to do, but obviously I'm doing it just for funsies here. Okay. All right, so what Cypress has done, has created a bunch of files for us. For this purposes here, we're not going to care about the fixtures, not going to care about the plugins, not care about the support. What we are going to care about is the integration. This is all the spec files. Every test we're going to create are going to be what's called spec files, and this is just a sample of what you can do with the spec files. I'm not worried about these, so I am going to delete them. And we're going to create our own. Now, I envision, in fact, I know that this card base will be the base, obviously, of all of our card games that we're going to be playing here. And it's going to be the base class for a bunch of different classes that are going to extend the base card class. So what I'm going to do here is for each integration here, I'm going to create a directory that will be the directory for each particular class, because we'll be adding classes in on the future as we create our actual playing cards for all of our games here. So let's create our first test, and we'll call it card.spec. Really simple. So what we're going to do here is the first thing we're going to want to do is we're going to want to import our card class. Now, we don't have a card class. We don't have anything like that already created. So what I'm going to do first of all is I'm going to create a completely empty card class, so at least the specifications when we do run it won't blow up on us. So what I'm going to do here is I'm going to create a directory. I'm going to call it source. Everything's going to be inside of a source directory. And within the source directory, I'm going to create another directory called card, because all my other playing cards will extend the card, so I want to have them all in different directories. And let's go ahead and create our JavaScript file called card. And this will be an export default class card. And that's it. I'm not going to have absolutely nothing else in it, because again, we're going to develop based upon our tests. So I want to have absolutely nothing within our card class. So we save that. Let's back over to our spec. Now we can import our card and start writing tests. Now I'm using Cypress here, but it works a lot like if you're used to Jasmine or Mocha or something like that. It works very similar to those. So the first thing we're going to do is kind of group our tests together. And our first test, we're going to basically be the card creation. And this will be the section that's going to create the card, basically test the constructor itself. The second section we're going to take a look at will be locating the card. Because basically what we want to do here, locating, spell it right, the card. Because basically what we want to do here is we're going to be able to create the card. But the next thing we want to be able to do is be able to find the card. And basically what I mean by finding the card is that we want to be able to know that if this card happens to be a particular suit, or if this card happens to be a particular rank, or if this card happens to be a particular value, we want to be able to locate it. Or if the card happens to be all three at one time, we want to be able to locate that particular card. And that's pretty much all we really want to do with these cards here. So the first thing we want to do here is in the creation, we want to be able to create now our cards. So what's our test going to look like? Well, the first test, it should create a blank card. That's one of our tests. Next test, we should be able to create a card that was how we say card specified by the parameters. All right, we got that. Okay. All right. Now I do remember one other thing I wanted to test is that I wanted to test read-only properties, because some of our properties are going to be read-only, and we'll get into that here in just a second. I'll explain that in a little bit more detail in just a minute. I also want to test properties that are read-write properties. So I'm going to make sure I can basically change these properties if I need to change them. And consequently, the read-only I should not be able to change. So we should be able to create a blank card, and we should be able to create a card specified by parameters. And that's pretty much it, because all we're testing for is just the creation itself. All right, what about, all right, well, actually, let's go ahead and finish up the test itself. So the test is going to be real simple. We should be able to create a blank card. So there's a blank card. So what are we going to test for? We're going to test to make sure if it is actually an instance of card. That's really all there is for that test. So we're going to create a new card, and we're going to test to make sure that it has actually created the instance of the card. Now we should be able to create a card specified by the parameters. So let's do constant card equals new card, and we will put up card parameters. Now, where are card parameters? Let's go back at the top and let's define ourselves some parameters. So remember, we have three different properties that we're going to be taking a look for. So we're going to pass it at the very least three different properties or three different parameters. Oops, get it right. Three different parameters into the card. And those three are suit, which we'll call suit. Of course, it doesn't matter what we call them here. We're just testing. Rank, which would be rank. And finally, value, which would be value. Yeah, I'll just make it 1. What the heck? Doesn't really matter. Value can be absolutely anything. So we got card parameters. Let's make sure we spell things correctly. There we are. So now we're creating new card parameters. And notice my IDE is sitting there saying, hey, it's all underlined. And the reason it's underlined is expecting 0 arguments because we have nothing inside of our card. So obviously it's going to start telling me, hey, you got problems here. That's okay. Of course, I always have problems, but the IDE is telling me I've got problems, but I know I've got problems. I'm not going to worry about it. So what are we going to expect? Well, we got our three particular properties. So we want to expect that our card.suit to equal card parameters dot suit. Same thing with rank, and same thing with value. And rank and value. So if it passes all three of those, that means that we have actually created our card with the suit, the rank, and the value. So that completes the card creation. Now, let's test the read-only properties. So the way I'm looking at this thing is that when you create the card itself, the suit of the card is usually predetermined by the card itself. If you think about a printed card, you can't change the suit of the card. So the suit is going to be one of our read-only variables. Well, same thing with the rank. I mean, you got an ace, a two, a three, a king, a queen, jack, whatever. The rank can't be changed either. So I'm going to also make rank a read-only property. So I'm going to test to make sure rank is read-only. Finally, we have value. Now, value is really dependent upon the application itself. So value, I'm going to create as being a read-write one. So that's going to go in the read-write description. So let's take care of our two read-onlys. Now, whenever we set up within JavaScript, if we're going to be setting up our properties here using getters and setters, which I'll explain when we get to the card section, and when we get to the card section, when we create the card, which is next video. If you have a getter without a setter, then that property is read-only. And if you try to change that property, it's going to throw a type error on you. So what we're going to test for here is to make sure that we get a type error. So let's say constant card equals new card. And we're going to put it in a try-catch block so that we can catch the error. And what we're going to do is we're going to say card.suit, because we're going to test suit first, equals, oh, bad. Now, why am I saying expect true to be false? Because obviously that's stupid. Why should we expect true to be false? Well, the reason we're doing that here is that if this works, if we are able to change suit, then it's going to continue on to the next line. But I don't want to be able to change suit. So if I was able to change suit, I want this to flag as an error. So this is the way I've always done, to automatically force an error. There's probably better ways of doing it. Basically, you have to look at the documentation. But if suit can be changed, it's going to go to line 26, and I want to make sure it throws the error, or the expectation error, the assertion. I want to make sure it throws the assertion to saying, hey, we got an error here. Stop. You should not have been able to change it. Now, what I want to do here is inside the catch. It means we did get an error. I want to make sure it's the correct error. So we're going to say to equal type error. And actually, I want to say .name because the error condition is going to have a name. It's going to be called type error. Because I expect to have a type error there. If it's not a type error, then I've got something else that has gone wrong. So that allows me to test suit. So we've tested suit. Actually, what we need to do here is let's do it right. Let's see. Should not be able to change the suit. And let's move this into there. Good. Suit and rank are our two read-onlys. So we should not be able to change the rank. So let's change the rank to bad, and everything else should remain the same. I should get the true equals true to be false if it happens to be able to be changed, or that I should get a type error. So this completes our read-only properties. Those are on two properties that are going to be read-only. Our read-write property is the value property, so we should be able to change the value property. So let's do this. It should be able to change the value property. We'll just say change the value. What the heck. Alrighty, constant card equals new card. Card.value equals 2. And I should be able to say expect card.value to equal 2. So now notice I didn't have a try-catch loop. Now why? Because if I am able to change the card.value, then I'm not going to get any kind of errors, and it should change it to 2. And I know from up here that value is going to pretty much be undefined at this point, because I don't know what the value of value is because I'm not passing anything. So that's one of the things I'm going to have to determine, is that what am I going to put there for value when I create it, and there's no value specified when the creator is called. And I'm going to tell you right now, it's probably going to be undefined. So I can by changing this, I know I can change it, and I should be able to expect that to change. If it throws an error, it's going to throw an error, and we know we got something else wrong. So that completes our read-write properties. Finally, locating the card. Now, there's actually about 5 different ways to be able to locate, actually 4 different ways to locate the card. We want to find out, basically say, hey, is this card when I mean by locating the card, we want to check to make sure if it is a certain type of card. Is this card a certain suit? Is this card a certain rank? Is this card a certain value? And is this card a combination of the suit, the rank, and the value? So those are the 4 different properties we're going to do here. So locating the card, it should be able to find the card based upon suit. I always hit that wrong. It should be able to find the card based upon rank. It should be able to find the card based upon value. And finally, it should be able to find the card based upon all 3 properties. Okay, so let's kick it up. All right, so constant card equals new card, and we're going to call the method isSuit, and we're going to pass it. Actually, what we want to do here, messed up. All right, so what we want to do here is we want to do card parameters, because we want to basically make sure we have the card parameters correct. So we're passing these card parameters, so we know we have a constant set of cards. So we want to make sure isSuit card parameters dot suit. This is going to be a Boolean value, so it's going to be say to be true, and that fixes up the suit. How about the rank? And we'll call that method isRank. And then finally, nextly, we're going to try isValue. And then finally, we're going to do isCard. Now, this is going to be a little bit different. isCard, what we're going to actually pass is an actual card. So we got new card parameters. We're going to make that card 1. Constant card 2 equals new card parameters. So these should exactly match each other. Parameters. Okay. So card is card, and what we're actually card 1 is card 2. So this is a little bit different, is that instead of a passing, since we're checking for the entire card, I want to check if one particular card is equal to another particular card. Just in case you throw, a couple of ace of spades up your sleeve or something, 2 people throw two ace of spades at the same time, and that pretty much will tell you that there might be a problem. And what am I missing here? Oop, I got missing a parentheses. Okay, so that takes care of those particular parameters. And finally, there's one thing I just thought of here, is that applications are going to be using this base class or extending this base class, and they're going to want to be able to make their own comparisons. Yeah, you can definitely have a comparison for a suit, a comparison for a rank, a comparison for value, and a comparison for all 3, which is this card. But you know what would be really good is that if we had some sort of possibility to be able to allow the application to be able to compare 2 cards together using a function that is passed by the application. So for example, value can be anything. And so if value is a complex object, isValue is not going to work, and isCard is not going to work, because we're not checking, we're not doing any kind of deep checking of the value. We're just assuming the value is basically a simple primitive value. And so if you got some sort of complex value there, like an object or an array or something like that, it's just going to mess up on you. So we're going to need some sort of compare method. Now I'm going to go back to my, or go back into some design pattern days here, is that what I want to do here with the compare method is that I don't want to define anything in the base class because I don't know how an application is going to want to compare two different cards. So what I'm going to do is when I create, this is something I'm thinking about as of right now, when I create the card, I'm going to leave the compare function to return undefined all the time because I don't want to define any comparison function. I want the application to do it. So if the application wants to be able to define their own card comparison routine, then what they will do is that they will extend the card class into something else, and then that card class will pass in its own compare method by extending the compare method itself on the card and writing its own compare method, and everything will work like a champ. So I'm basically kind of creating the compare method to be an abstract method. And I'll explain a little bit more about that when we create it. So we got one more thing here to do is it should return undefined for the compare method. So if I compare two cards together, and we'll just copy those two. If I compare two cards together, I should expect card1 dot compare card2 to be undefined, because I'm going to basically want to have the application define the compare, not my base class. So I'm just going to completely return undefined. And that should be it. You want to see how the test run? It should bomb out on you. So let's clear off the screen and let's go npm run test. And error, no test specified. You know why there's no test specified? Because we forgot to put into our testing our test script. So I'm sorry, our package.json, our test script. So let's change our test script here. Because remember, I just did it npm init, so this is the default for npm init. So to run the test, we're going to go Cypress run. And that will allow us to run the test. Let's save that off. Let's now go back and run test and see what happens. Now, we should expect a whole bunch of these, if not all of them, to completely die on us. Actually, one of them should work. You'll find out here in just a second. So we'll let it do its thing. Actually, it looks like two of them worked. There we go. Card.spec. 8 of them failed. 2 of them actually passed. Which 2 passed? Should create a blank card. And that's correct. We were able to create a blank card. Ta-da! Because there's no constructor or anything. Of course it's blank. There's absolutely nothing there. All we want to do is test for the instance of card. And should be able to change the value. Well, of course we could, because it's a public property. So we could change any public property we want to. Even though ones that have not been defined by default, JavaScript, if you change something, JavaScript will think, oh, okay, we just want to change this value here. Sure, you go right ahead and change it. So those two actually worked straight out of the box. Woo! Who would thunk? But that pretty much completes our specifications, our card specs. So now we should have a complete working card base once we complete the code. So what we'll do now in our next video, in the next video in the series, is that we're going to create the actual card class, and we'll be using this card specifications to be able to tell us what we need to create inside the card class. So like I said, that's our next video. Cue it up, take a look at it, and we will see you later.